Bismillahirrahmanirrahim. Hello everyone. I hope you are all doing well. In this short video, I will try to explain to you how we can use Techlog to load well logs and to display them, and also how to calculate some petrophysical properties. So this is my main window in which I can have all the necessary tools to do all my work. I can create new project if I want to. I go here, project, and I can create a new project. I give it a name and then I can run it. And if I have problem with license, I have to go to licensing and module manager. So I can activate all the licenses which are not maybe active. Now, once I'm ready, I can go and load my logs. So for example, I have a couple of wells. So I will bring my well from the last file, and once I drag and drop, so I have two options. I can drag and drop, or I can go to import file from here. So here I can have a look at my logs which I have in that well. If I'm happy with these logs, then I will select them and I will import them. Otherwise, I can delete it and I can bring another last file. So if I'm not interested in all these logs, I can choose the logs which I'm interested in, and I will skip the ones which I'm not interested. So for example, if I'm interested only in this part, so and this part I'm not interested in, I can just select it and then it will come to me. So here I have only the logs which I highlighted. Okay, and of course the depth will come with all the logs. And now we can close the selection window or the loading window. Now the first thing I have to do, I have to check the family or the names of the logs which I have, because some of the logs they might have different names that I may not be able to identify, but I can see them from the family to which they belong. And if it happens that maybe I want to modify or to assign a family to one of the logs, so I have to go to the log and then I will try to click on reassign, and then here I can reassign the family manually or automatically. So if I will choose by manual picking or manual selection, so here I can choose, for example, deep resistivity, and this is my deep resistivity. So now you see it's defined, and the unit is ohm meter. This one is the medium resistivity, and they can also edit in the same way. So here I can have medium resistivity, and it will be in the same way. And then now I can start plotting my logs. I go to plot. In the plot, I have log view, I have cross plot. So the cross plot will show me how we can cross plot logs. And this can happen in single well or in multi well. Now I go to log view. In log view here, I will select the logs which I want to analyze. So I will start by the gamma ray, and I see that the scale is too much exaggerated. So I will adjust it and make it 1:1. And then I will scroll up and down and try to squeeze it. Okay. And then now I can go to the next. So the next step, now what I can do, I can squeeze it and choose other logs which I can highlight. And the first thing I can do, for example, I can adjust my cutoff scale or my cutoff line, which will define the shale and sand for me on the gamma ray, and then I can bring the other logs. So this is the gamma ray. I can then bring the Roby. I can then bring the neutron. I plot it in the same track with the Roby. Okay, so they are here. So here I see my two logs, which are uh, showing very high similarity and correlation because they are uh, same nature or same porosity type or same log type, which is porosity. Now what I can do, I can see and I can look for the separation between the two logs. So here I have a clear separation where one will increase and the other will also increase and or decrease. And so here, for example, I notice that the density is high and the neutron is will increase here. So then what I can do, I can highlight, for example, the two logs by pressing Control and clicking on the two logs, and then I can select the filling option. So this will show me how the logs will be separated into positive and negative separation. And then here I can see where I have a negative separation. Now next I will bring my resistivity log. So this is the resistivity or the deep resistivity. And I can also color it if I want. I can just select my log and then here I can choose color, one single color for the low and for the high resistivities, or I can select a color bar, which I can use for the gradual change of my resistivity. So for example, I will choose this color bar or palette. And now what I can do next, I can maybe bring other logs which I might be interested in. So for example, I can bring the RM and see how it will look like. And here I see that RM looks like it's linear scale. So what I can do, I can go to uh, back to home and then properties editor. And then I go to my log and click on it. So I will click on it on my log, and here I see it's my RM. I go to horizontal axis, which is defined as a family. So I will try to select it as user, and here I can choose my log to be in logarithmic scale. And here I will try to make it in the same range, 2000, and the mean is 0.2. So now they are almost identical to one another. Okay, and now what I can do, I can, for example, bring the DT, the sonic, and I can then go to petrophysical properties to calculate. So here I have a couple of tools that can help me to express and to extract number of properties. So for example, if I go to quanti or quantitative plots, for example, here I can find the Piquet plot, which we have seen in the class, which is nothing but a cross plot of porosity against resistivity, or also Thomas Steiber plot. Uh, and this one we did not cover it. So now if I want to calculate petrophysical properties, like for example V-shale, I can select combined methods where I have a couple of inputs, or I can select the way or the option where I have only one log. For example, the gamma ray. I will choose the gamma ray, and here my gamma ray is already selected. And now I will select it here. So this is the gamma ray. So I select the gamma ray and then I will create it. So this will create a workflow for me. And this workflow, I can apply it on all the wells which I have. Imagine I have 20 wells. All these 20 wells, I can drop them here and this workflow will be implemented on all of them. So one thing here I have to put in my mind is that I have several options. So I can calculate my parameter and just display it without saving it. I can save it without displaying it, or I can save and display. I will choose save and display. Okay, and then what I will do, I will drag and drop my log here. So I see that my parameter is already selected, my gamma ray, which is will be the input. I can check the parameters. Parameters are the well name, the data set, the zone. Here you can specify the zone, or you can leave it as all. And for the gamma ray of the matrix, for example, this is the clean formation, is 10 API. The one which is um, the max, which means the shale or shale baseline. So here it's 100 API. I can make it, for example, 180. And based on what I can decide, I can come here and I will take the cursor and see how high is my my gamma ray. So I see it's around here, for example, it's around 100, it's reaching 150 or more. So I will make it 180. The clean one is around 20. Okay, so or some it can go even beyond than that or lower than that if I will check the entire log. So then what I will do, I will click on save and display. So this will calculate my V-shale. And I can see I have V-shale gamma ray here. So, and now I don't want to display it. Um, I don't want to save it. No. So then I will display my calculated log. It's V-shale. So this is my V-shale, which will show me how much of shale content I have. So here I have a huge amount of shale, and here I have less. I have clean formations, and here I have very dirty formations. Now, suppose I want to calculate, for example, the porosity. Porosity, I can find it here, and here I go to porosity, and I can find total, and I can find the neutron, and also the effective. So I can choose, for example, the neutron density effective. This one, it will require the neutron porosity. I will select only my well. So um, my neutron is named NV. My bulk density is rho b. This is my rho b. My shale volume, which I just calculated, is this one. Resistivity, I have it here, but I can exclude it because it's optional. These are the mandatory parameters. These are optional parameters. So this will help me to calculate my effective um, porosity. So it will come here, and then when I click on it, you see here as input. So this is my neutron, this is my rho b, this is my V shale, and now I will choose save. I don't want to display it. I will run it. So then I can have my this is my total porosity from neutron and density. This is my effective one. So I can bring my effective. So this is my effective porosity. And it shows me that I have at the shale level, I have low neutron, and um, I can compare it with the total one. So the total here, you see, I have very high total porosity at the shale, but when I calculate the effective porosity, I see that I have very low porosity at this zone because actually all this amount is just total and it's not effective and it's not beneficial. And here I have high neutron porosity, especially at reservoir interval. Okay, now what I can do, lastly, I can calculate, for example, the saturation using Archie equation. You can use actually Indonesian and total shale and all these equations and see which one will go best with my well. But for simplicity, I can choose the Archie equation. So for the Archie equation, I will choose my well. And for the resistivity of my formation, I will choose again the deep resistivity, or I can choose the true resistivity. For the porosity, I will choose the effective one and see what it will give me, and then create. So now you see I have the third workflow. First one for calculating B shale, second for effective porosity, the third one for water saturation. And these are the input, porosity um, and the deep resistivity. For the parameters, you will notice that I have a couple of parameters which you have seen in the RT equation, which are the A and M and the porosity. So if you rotate here, click on rotation, it will show you the parameters which are needed. So the RW, this RW, it can be modified if it's not correct. So here we are using default parameters, two for the N, for the M, and one for the A. Now, if I'm happy with these parameters, then I go and click on save. So then this will give me my BVW, which we have studied in the last um, lecture, and it can calculate for me the water saturation using Archie. So then I will bring this is the water saturation using Archie. It shows me that I have hydrocarbons here, but in the shale zone I have nothing. Okay, so lastly, for the workflows, for the cross plots, so I'm done with now the different plots. Now I can do something. I can highlight my reservoirs. For example, I can go and pick the reservoir as we did in the class or in the lab. So for example, I will add new formation. I will create this is reservoir one top. So I will select it here and then I go and highlight it. And this will be my top of my reservoir. Okay. And then I will come to this sign of refresh and then it will be refreshed. And then I will go and choose the reservoir one bottom because I might have other reservoir. Okay, and then I will come and click on it and then it will be active and then click here. So then I have now, this is my top and this is my bottom and I can come and refresh it. Okay, so then, so now I have my top and my bottom of my reservoir. If I want to study the cross plots as we did in the class or in the lab, so I have to go to here. So this is cross plot window. In the cross plot window, I have to choose what type of log I want to cross plot because we have so many logs that we can cross plot against one another. For example, I can bring my say dt, for example, against my rho b. Okay, so this is dt on the x-axis and rho b in the y-axis. And now I can add another log to as a color. So I will add it here. So I will have good maybe insight and good idea about what is making um maybe linear trend and what is making non-linear trend and what is making a large density and lower density. Then what I can do, I can go, for example, and choose templates if are available. So, for example, here I have general template. I have bulk density against the sonic. I click on it, so here it will come. So it will show me how the sonic is changing with. Okay, so I can go outside and I can scroll up and down so that I can zoom in and zoom out. Okay, so this is in brief how we can use Techlog. And now the interpretation is another thing, is another thing that I have to use all what I have learned in the class to come up with a good interpretation that will follow the logic and will follow the geology. So look how many reservoir zones I have found. The best reservoir is actually here, where I have minimum water saturation. It means maximum hydrocarbon saturation. I have good high effective porosity, and I have high resistivity, and I have a very clear negative separation. So thank you for watching, and I wish you all the best.